All right, this chapter begins our discussion of probability distributions. What is a probability distribution? Well, it's a list of every possible result to an experiment, along with the probability of obtaining that result. Now, what probability distributions allow us to do? It allows us to help define problems that involve uncertainty. They also help us to compute some complex probabilities, and it provides some structure to uncertainty. It helps us really get a handle on it. Now, probability distributions can be for discrete random variables, and that's what we're going to see in this chapter, or they can be for continuous random variables, and we're going to see examples of that next chapter. Here's an example of a probability distribution for a single flip of a coin. A single flip of a coin could result in heads or tails. The probability of heads is 50%, the probability of tails is 50%, and the sum of all the events of a probability distribution have to add up to equal to 1. If I was going to roll a die, well, these is the probability. What's the probability of rolling a 1? It's 1/6. So if I list every possible outcome, I have a probability distribution. Now, a useful concept in business is the concept of the expected value, which is basically the mean of a probability distribution. Suppose that you're invited to play a game involving the flip of a coin. If the flip results in tails, you'll win $1,000. If the flip results in heads, you'll lose $600. Would you like to play this game? This is the probability distribution here. If it comes up tails, I win $1,000. The probability of that happening is 50%. If I roll heads, I lose 600, the chance of that happening. The expected value of a probability distribution is found by taking this formula. You take the sum of x times the probability of x. So I would take 1,000 times 0.5 and 600 times 0.5. I'd get a positive 500, a negative 300. I then sum it, and I get 200. This $200 is called the expected value. Now, what's very important here is the interpretation of the expected value. If I repeat this experiment a large number of times, you will average winning $200 each time that you play the game. That's what you're going to average. But the expected value only has meaning if you're going to play something a large number of times.